All right. Today we are cracking open what is, without a doubt, the single most important AI paper of the last decade. We're talking about a 2017 publication from Google researchers that didn't just move the goalposts, it basically invented a whole new game. If you've ever just sat back and been floored by ChatGPT's ability to write a poem, or how Midjourney can conjure up a masterpiece from just a few words, you've probably asked yourself this exact question. The jump from those clunky old chatbots to genuinely creative AI, it feels like magic, right? Well, here's the thing. It's not magic. This entire explosion in what AI can do, you can trace it all back to one core concept. An idea laid out in a paper with a title that was deceptively simple, but also incredibly bold. Attention is all you need. Okay, so let's dive into this. To really get why this paper was such a big deal, you first have to understand the huge problem that AI researchers were totally stuck on. And it was all a problem of sequence. See, before 2017, the best models out there, they were called recurrent neural networks, or RNNs, had this massive limitation. They had to process language one single word at a time. And that made them painfully slow. But even worse, it made them forgetful. This whole step-by-step process, it was like a giant game of telephone with the AI. It reads the, makes a little mental note. Then it reads cat and has to update that note. By the time it gets to the end of a long sentence, that crucial context from the very beginning, it's all fuzzy. Or sometimes it's just gone. This made it nearly impossible for the AI to figure out how words at the beginning of a sentence related to words at the end. And this, right here, brings us to the aha moment. The researchers proposed this completely radical new architecture that solved the sequential problem by just getting rid of sequence entirely. This one line from the paper's abstract, this is everything. They didn't just tweak the old models, they completely threw them out. They built something brand new, from the ground up, based on a single powerful mechanism called attention. So what is it? Well, it's all thanks to this mechanism called self-attention. Imagine this. Instead of reading word by word, the model gets to look at the entire sentence all at once. So when the model sees the word it, self-attention lets it instantly scan every other word in the sentence and calculate which ones are most relevant. It can immediately see that it refers back to the cat from 5 words ago, not the mat from 2 words ago. All of a sudden, distance just doesn't matter anymore. Okay, so if self-attention is the engine, how do you actually build the car? Let's take a quick look inside the full transformer architecture that it powers. The full architecture is actually pretty elegant. It's got 2 main parts, an encoder, which is there to understand the input text, and a decoder to generate the output. But the real magic is inside these parts. It's called multi-head attention. It's kind of like having 8 different specialists read the same sentence all at once. Each one is looking for different kinds of connections. Maybe one is focused on grammar, another on who's doing what to whom. You get the idea. And right here, this is the brilliant question that the authors had to solve next. Think about it. If you get rid of processing things one by one, you completely lose the natural order of the words. The cat sat on the mat just becomes a random jumble of words. So how do you fix that? The solution they came up with is called positional encoding, and it's just brilliant. Think of it like giving each word its own unique GPS coordinate. Before the model even really sees the words, it gets this mathematical signal that basically tells it, hey, this is word number 1, this is word number 2, and so on. This gives the model a perfect map of the sentence's structure, so it knows the word order without ever needing to read it in order. Now, a beautiful theory is one thing, right? But the researchers had to actually prove that this new model, the transformer, worked better in the real world. And wow, did it ever. They tested it on the standard benchmark for machine translation. And the transformer didn't just beat the old state-of-the-art models, it completely shattered the old records, setting a brand new bar for performance. Now, to put that number in perspective for you, researchers in this field usually fight for fractions of a point. Gaining over 2 full points in a single jump, that's like a high jumper not just clearing the bar, but landing on the other side of the stadium. It was just an unambiguous, total game changer. But here's the real killer feature. The one that truly changed everything. It wasn't just better, it was so much more efficient. Because that whole attention mechanism could be parallelized, you could calculate it all at once. The transformer hit these record numbers while costing just a fraction to train compared to the older models.
So this wasn't just a win, it was a revolution in efficiency. Better, faster, and cheaper. And that, right there, is the key that unlocked our ability to train these things on a truly massive scale.
So, okay, a 2017 paper about machine translation. Why does that matter so much to you right now using AI today?
Because that exact architecture, the encoder, the decoder, the multi-head self-attention, all of it is the fundamental building block of pretty much every single generative AI tool we use today. You know the T in ChatGPT? It stands for transformer. It is the engine inside everything.
The story of this paper really proves that sometimes the biggest leaps forward don't come from just more data or more computing power, but from one elegant idea that removes a single critical bottleneck. Attention solved the problem of sequence. So the real question now is, what's the next fundamental limit in reasoning, in understanding, maybe even consciousness that's just out there, waiting for its own attention is all you need moment?